Hey guys, it is Monday, October 5th. Crazy how the school year's already flying. Well, on Friday, you took your mid-unit test, and might I say, they were fantastic. I'm very, very proud of you guys. The class averages were phenomenal. So obviously you are understanding how to solve a system, okay? And as you figured out on Friday after the test, you are now talking about linear inequalities. So graphing a linear inequality on a coordinate grid, okay? And just to refresh your memory, you are, if I give you an inequality that is greater than or less than, you are doing a dotted line. If I give you an inequality that's greater than equal to and less than equal to, it is a solid line. Okay, so that's the first distinction. Okay, whereas just a linear equation is just a solid line because the solution is just that line. With a linear inequality, now we break it down into a solid line and a dotted line. But the difference between the two, a linear equation and a linear inequality, is now you have to shade on an inequality because it can be a range of answers. So if I give you greater than equal to or greater than, you know you're shading above the line. Less than or less than equal to is below the line. Okay? Now, on Friday, you just graphed one equation. Well, now today we are going to graph a system of linear inequalities. So anytime I say the word system, right off the bat, you should be thinking more than one equation. Okay? You should have picked up a worksheet that has a 21 on the front. We are going to look at the back side. Okay? And I'm going to use number 1 and number 3 as your example, and then you are responsible for doing the rest of the worksheet for homework. Okay, so just to recap, I said it, but I just want you to write it in your notes. Again, in your composition book, you took these, you wrote the next page is 10.5, and let's recap. And as I just said, greater than or less than is a dotted line. Greater than equal to, less than equal to is a solid line. Okay, so that's the type of line. Now you're shading. Greater than equal to or greater than is above the line. Less than equal to, less than is below the line. Okay, and again, what this does, by the shading, it separates your graph or your coordinate grid into a half plane. So, with number 1, these are both in slope-intercept form, so I can very quickly graph. I don't need to rewrite them. So the first one, my slope is negative 1 over 1. My y-intercept is 0, 1. So 0, 1. And when I walk out my slope, I go down and right, up and left. And looking at this, I don't want to underline it because I want you to get confused. This is a less than, so it is a dotted line with a straight edge. There's my dotted line, extending it all the way through the graph. And now you probably understand why. Because if you only did a small section, then your shading is going to look a little funny. Now, less than is going to be below the line. Okay? And I'm actually going to do this in 2 colors. Now, my second one, now remember, everything in this shaded area is a solution to that first equation. So if I were to pick a point over here, plug it in, it would make it true. If I picked a point over on this side, plug it in, it would make it false. Now my second equation, my slope is 2 over 1. My y-intercept is 0, 4. So 0, 4 is 2 over 1. So up 2, right 1, down 2, left 1. It has an equal sign, therefore it is a solid line. Now we're talking about this solid line, and what am I shading? Greater than, so everything above. Okay? Well, everything in purple is a solution to this equation. So if I picked a point anywhere in the purple area, it would make this statement true. If I picked a point anywhere in the non-purple, which would be all of this area, it would make that false. Now, remember, with systems of equations, we want to find where the two intersect. Okay, and if this was a system of equations, it would be this point. But because it's a system of inequalities, it is going to be an area. Well, so think about it. Where do the two areas overlap? And hopefully you said in the purple and pink area. So now everything in this purple and pink area would make both of these true. Now, don't leave it like this. You need to now go back in and color it darker for me. And let me know that that is the area that you're saying is the solution to this system. So again, if I picked any point in this area, plug it into both of those equations, they both would be true. If I picked a point anywhere outside, whether it be up here in the purple, down here in the pink, or right here in nothing, it would make them false. Now remember, if I plug a point in this purple area into my second equation, it's going to make my second true, but it's not going to make my first. Therefore, it's not a solution to both of them. Okay. Number 3. Now, as we've practiced before, both of these are in standard form. In order for you to graph them, you have to put them in slope-intercept form. So in order to put them in slope-intercept form, my first one I'm going to subtract x. So that gives me 2y is less than or equal to, less than negative x plus 4. Divide everything by 2. So the slope of my first line is negative 1/2. My y-intercept is 0, 2. So when I plot that, y-intercept is 0, 2. Slope is negative 1/2. So down 1, right 2. Up 1, left 2. It is less than, therefore it's a dotted line. And less than means below. I'm going to do this one in pink. My second equation, I need to move 3x over. So y is greater than 3x plus 1. Your slope is 3 over 1. And your y-intercept is 0, 1. Y-intercept 0, 1. Slope of 3 over 1. So 1, 2, up 3, right 1. Down 3, left 1. It's greater than, so it's a dotted line again. And greater than means above, so I'm over here. Okay. Now, where is the area that has both the pink and the purple? This section right here. So I'm going to make it very dark so I don't get it wrong. Now again, if I picked a point in this area, plug it into both. It will make both statements true. Therefore, that's the solution. If I picked an area in just the pink, this was my purple one. If I picked a point in my pink, it would just make the pink true. It would make the purple false. And the same is true with the purple, but the reverse. Okay. Again, we were trying to find the system of inequalities. We are finding the area where these two graphs overlap. Now think about it. Could there ever be a time where they don't overlap? I want you to think about that and bring that answer to the class tomorrow. Okay. Now, your homework tonight is for you to finish these two and to do the 6 on the front page. Hope you guys have a great night, and I will see you tomorrow.